Hello students, this is Nikilian, Assistant Professor, Department of Civil Engineering, AIT, Mangaluru. In our previous session, we had discussed about the different classification of soils and how to determine the strength of soil using CBR test. Now, today in this session, we shall discuss how to determine the strength of soil using bearing plate test, as well as we also continue our discussion on aggregates and bituminous materials which are used in the construction of pavement. Plate bearing test. The plate bearing test is used to evaluate the support capability of a subgrade, bases, and in some cases complete pavement. Here we all know that the subgrade and base are the main courses which are responsible to transfer the vehicular load to the hard strata without causing any damage to the pavement surface. Hence, it is very essential to determine the strengths of these courses. Hence, to determine the strength of subgrade and bases, we will use plate bearing test. The data obtained from plate bearing test can be used for both the designs, that is for the design of flexible pavement and rigid pavement, because in case of flexible pavement and in case of rigid pavement we will be having same courses like subgrade and bases. So for construction of subgrade and for the construction of base in flexible pavement and in rigid pavement, the material used is soil. Hence the results obtained from plate bearing test can be used for the design of flexible pavement as well as for the rigid pavement. In plate bearing test, a compressive stress is applied to soil or pavement layer through rigid plates relatively larger size, and the deflections are measured for various stress values. So here how the strength of a soil is determined is the compressive stresses is applied to the soil or onto the pavement layer through a rigid plates, and the diameter of the plates will be normally large, and here the deflections are measured for various stress values or for different loads. The deflection level is generally limited to low value in order of 1.25 to 5 millimeter, and so the deformation cost may be partly elastic and partly plastic due to compaction of stressed masses with negligible plastic deformation. So here we are going to measure the stress values for the lower value of deformation. So normally if the level or if the depth of deformation or settlement is 1.25 to 5 mm, then we will measure the value of stress, and at this stage the deformation of the soil is caused due to partly plastic and partly elastic. So the soil will be in the form of elastic and partly plastic due to the compaction of a stressed mass. The plate bearing test has been devised to evaluate the supporting power of subgrades or any other pavement layer by using plates of larger diameter. So the plate bearing test is modified, or the plate bearing test is being used to evaluate the supporting power of the subgrade or any other pavement layers. So to determine the strength of the subgrade or any other pavement layers, we can use a single plate or a series of plate of usually larger diameter. The plate bearing test was originally meant to find the modulus of subgrade reaction in Westergaard's analysis for wheel load stresses in cement concrete pavement. So the plate bearing test was initially meant to find the models of subgrade reaction in Westergaard's analysis. So Westergaard analysis is done for rigid pavement like concrete pavements. So for this analysis, first we were using plate bearing test. So here the modulus of subgrade reaction K, The modulus of subgrade reaction is denoted by letter K and is defined as the pressure sustained per unit deformation of subgrade at specified deformation or pressure level using specified plate size. So this is called as subgrade modulus of subgrade reaction, which was used in the analysis of rigid pavements. So here in this picture you can see the setup for plate bearing test. So this is the soil whose strength has to be evaluated. So it is a series of plates with larger diameter, or it is also called as stacked plate. So above the plate we have a hydraulic jack which is capable of causing deformation, and above the jack we have a platform for the application of a load. So here we have a dial gauge for the measurement of settlement of the earth, and we also have a pressure gauge to measure the value of load applied or to measure the value of stresses. So in this picture you can see the actual setup for the determination of strength of a soil. So here we have two gauges which are used to determine the deformation or settlement of the soil. So this is a dial gauge which is used to measure the value of stress or the load. So it is a circular plate of larger diameter. Above the plate we have a hydraulic jack, and above hydraulic jack we have a platform for the application of load or a stress. Now let us see the test procedure. The test site is prepared and loose material is removed so that the 75 cm diameter plate rests horizontally in full contact with the soil subgrade. You can see here. So this is the area where the strength of soil is to be determined. So when we are going to start the test, before that we should ensure that the plate is in full contact with the soil of which the strength is needed. So for that what we will do, the loose particles of the soil on the top layer is removed and the ground is made horizontal, so that when the plate is placed on the ground surface, the plate is in full contact with the soil particles. So after that, in the second step, the plate is seated accurately, and then a seating load equivalent to a pressure of 0.07 kg per centimeter square or 320 kg for 75 centimeter diameter plate is applied and released after few seconds. So after placing a plate on a soil surface or on a ground surface, to make the plate settle, a initial load is applied. A initial load with a pressure of 0.07 kg per centimeter square is applied so that the plate will get settled tightly and the full surface of the plate will be in contact with the soil particles, and after that the load is removed. So in the third step, the settlement dial gauge is now set corresponding to zero load. So here we have dial gauges to measure the settlement, and there is a dial gauge to measure the stress. So the values of all the dial gauges are set to 0 after the removal of initial load. A load is applied by means of jack sufficient to cause an average settlement of about 0.25 millimeter. So here you can see hydraulic jack, and this hydraulic jack is sufficient to cause a deformation of 0.25 millimeter for the applied load or applied stress. When there is no perceptible increase in settlement, or when the rate of settlement is less than 0.25 millimeter per minute, the load dial reading and settlement dial reading are noted. So after application of load, and when the deformation or settlement of the ground surface is less than 0.25 meter per minute or 0.25 millimeter per minute, then in that condition the values of settlement dial gauges and the value of stress dial gauges noted. Deflection of the plate is measured by means of deflection dials placed usually at one-third point of a plate near its outer edge. See, these are the dial gauges which are used to measure the deformation of a soil or deflection or settlement of a soil, and see the position of this dial gauges. So these dial gauges are placed at the outer diameter of this plate, rigid plate, and it is placed at 3/4 diameter. To minimize bending, a series of stack plates should be used. As in this picture, you can see a circular plate of diameter 75 centimeter. So in some important projects, we need to use a series of plates like this, because if we use a plate, if we use a single plate, sometimes when the load increases, the plate may undergo bending or the plate may deform. So when the plate deforms, the results obtained will not be accurate. So in order to obtain the accurate results, we need to use a series of plates like this. Average of 3 or 4 settlement dial readings is taken as the settlement of a plate corresponding to the applied load. So when we apply a load, the 3 or 4 settlement dial readings are taken, and average of these 4 readings will be the settlement of a soil for a applied load. And that means we are going to use 3 or 4 settlement dial gauges in the plate bearing test experiment. Load is then increased till the average settlement increases to further amount of 0.25 millimeter, and the load and average settlement readings are noted as before. The procedure is repeated till settlement is about 1.75 mm or more. So once when the plate reaches a depth, or when the soil undergoes a deflection of 0.25 millimeter, the load is noted down. And again, after noting down the load for the deformation or settlement of 0.25 mm, again the load is increased, and the load is increased up to further settlement of 0.25 mm. So when further settlement of 0.25 mm occurs, the loading is stopped and the load is taken. The corresponding load for settlement of 0.25 mm is taken and it is noted down. And the same procedure is repeated until the settlement is 1.75 mm or more. That means for each 0.25 mm settlement, the load is noted down. Allowance for worst subgrade moisture and correction for small plate size should be dealt properly. Sometimes in the site, what happens, the subgrade or subsoil may be having some water content. So in such cases, there will be settlement, there will be more settlement. So for this special cases, we have to apply a proper correction. So not only for the moisture content, we should also apply the correction for the small size plates. A graph is plotted with the mean settlement versus bearing pressure. The pressure corresponding to settlement is obtained from this graph. So you can see a graph here. So this is a graph. Along x-axis we have mean settlement, and along y-axis it is mean bearing pressure. So this graph is plotted with the obtained result. So using this graph, I can calculate the required bearing pressure to cause a settlement. For example, if I want to know what is the pressure required to cause a settlement of 0.15 centimeter, so here it is 0.1, here it is 0.2, so 0.15 centimeter will be in between of these two, it will come somewhere here, and the pressure to cause a settlement of 0.15 centimeter will be, so I will draw a perpendicular from here. So after joining the curve, again I will draw a perpendicular. So this value will be the value of pressure required to cause a settlement of 0.15 centimeter. The modulus of subgrade reaction is calculated from the relation K is equal to P by 0.125 kg per centimeter cube. So here the Modulus of subgrade reaction, it is denoted by K, is defined as the pressure sustained per unit deformation of subgrade at specified deformation or pressure level using specified plate size, is called as modulus of subgrade reaction. So next we shall see what is aggregate and what is the role of aggregate and what is the parameters to select the aggregates for the construction of pavement. So we know that aggregate form the major portion of the pavement structure and they form the prime materials in the pavement construction. So aggregate have to bear stresses occurring due to the wheel loads and the pavement, and on the surface course they have to resist wear due to abrasion action of a traffic. Hence, it is mandatory to know about aggregate and to know the tests that has to be conducted on aggregate to determine its strength. So aggregate is a collective term for the mineral materials such as sand, gravel and crushed stone that are used with binding mediums such as water, bitumen, Portland cement, lime, etc. to form a compound materials such as bituminous concrete and Portland cement concrete. So aggregates, it is a collective term for the mineral materials such as sand, gravels and crushed stones. So aggregates means we have fine aggregates and we have coarse aggregates. So the particles lesser than 4.75 mm are termed as fine aggregates and particles having a size more than 4.75 mm are termed as coarse aggregates. So these are the materials that will bind with water, bitumen and Portland cement to form a compound material like bituminous concrete and Portland cement concrete. So by volume, aggregate generally accounts for 92 to 96% of bituminous concrete and about 70 to 80% of Portland cement concrete. So if I consider a bituminous concrete, in bituminous concrete, 92 to 96% is occupied by the aggregates. So it may be coarse aggregate or it may be a fine aggregate. So 96% of a bituminous concrete is filled with aggregate means we should think what is the role of aggregate in the pavement construction. And about 70 to 80% of aggregate is present in the Portland cement concrete. Aggregate is also used for the construction of base and sub-base courses for both flexible and rigid pavement. So the aggregates are not only used in top pavement surfaces. It is not only used in bituminous concrete or Portland cement concrete. Aggregates are also used in base as well as sub-base course for both the pavements like flexible pavement and rigid pavements. Aggregates can either be natural or manufactured. So natural aggregates are generally extracted from larger rock formations through an open excavation. Extracted rock is typically reduced to usable size by mechanical crushing. So aggregates we have two types. One is natural aggregates and other one is manufactured aggregates. So natural aggregates means these are the aggregates which are the disintegrated parts of larger rocks. So larger rocks are excavated through quarry and these larger rocks are further made into small pieces of required size using mechanical crushing. It is called as natural aggregates. So manufactured aggregates are nothing but it is the byproduct of other manufacturing industries. For example, we have a fly ash. So it is a byproduct in a thermal power stations which is used as a fine aggregate. So desirable properties. So what are the desirable properties of a aggregate? So the desirable properties of the aggregates are strength, hardness, toughness, durability, shape of aggregates, adhesion with bitumen, free from deleterious particle. So let us see the properties of the aggregates one by one. So first let us know what is strength. The strength of aggregate should be more because the aggregate used in the top layers are subjected to different loads and different stresses due to the action of traffic. Hence, the aggregates should be strong and it should have a very good resistance for wear and tear action. So crushing of aggregates should be very low as a result of the movement of heavy loaded vehicles. So hardness. The aggregates used in surface course are subjected to constant rubbing or abrasion due to the moving traffic. The aggregate should be hard enough to resist the abrasion action caused by the movement of traffic. The abrasion action is severe when steel-tired vehicles move over the aggregates exposed at the top surface. So toughness, resistance of the aggregate to impact is termed as toughness. Aggregates used in the pavement should be able to resist the effect caused by jumping of steel-tired wheel from one particle to another at different levels, causing severe impact on the aggregates. So severe impact like hammering is quite more on waterborne macadam roads where stone protect out especially after the monsoon. So the magnitude of impact increases with roughness of the road surface, speed of the vehicle and other vehicular characteristics. Next property of aggregate is durability. So the stone used in pavement construction should be durable and should resist disintegration due to the action of weather. The property of the stone to withstand the adhesive action of weather may be called as soundness. The aggregates are subjected to physical and chemical action of rain and the bottom water, impurities therein and that of atmosphere. Hence, it is desirable that the road aggregates used in the construction should have sufficient sound enough to withstand the weathering action. So next is shape of aggregate. So aggregates which happen to fall in a particular size range may have rounded, cubical, angular or flaky particles. It is evident that the flaky and elongated particles will have less strength and durability when compared with the cubical and angular particles of the same aggregate. Hence, too flaky and too much elongated aggregates should be avoided as far the possible because too much flaky and too much elongated aggregates will not pack effectively. There will be a large void gaps. So next property is adhesion with bitumen. The aggregates used in bituminous pavement should have less affinity with water when compared with the bituminous material. Otherwise, what will happen? The bituminous coating on the aggregate will be stripping off in the presence of water. Suppose when there is heavy rain, the bituminous coating on the aggregate will be stripped off due to the rainwater. Hence, the adhesion with bitumen properties very important in construction of bituminous pavement. And last property is free from deleterious particles. So the aggregates which are used in the construction of pavements should be free from silt and other organic properties. Then only we can use the aggregate effectively in the construction of pavement. So in previous slide we saw the properties of the aggregate. Now let us see what are the tests conducted on the aggregates. In order to decide the suitability of aggregate for use in pavement construction, the following tests are carried out. First one is crushing test, abrasion test, impact test, soundness test, shape test, specific gravity and water absorption test, bitumen adhesion test. So these are the tests which are conducted on the aggregates to determine whether the aggregates are suitable for the use of pavement construction. Now let us see what is the crushing strength and how the crushing test is done in the laboratory or in the field. So this test is standardized by IS 2386 part 4 and used to determine the crushing strength of the aggregate. So what is the test procedure? To know the crushing test or crushing strength or crushing value of a aggregate. So take a dry aggregates passing through 12.5 mm sieve and retain on 10 mm sieve, and these are filled in a cylindrical measure of 11.5 mm diameter and 18 centimeter height, and the aggregates are filled in each layer. Each layer is tampered by giving 25 blows with a tamping rod. The test sample is weighed, and let us consider the weight of test sample as W1, and it is placed in the testing machine. So here the test standard consists of a cylinder of 15.2 centimeter diameter, which is 14 centimeter height, with a base plate in three layers, each layer being tampered again. The plunger is placed on the top of a specimen and a compressive load of 40 tons gradually applied at a rate of 4 tons per minute. Then the crushed aggregates are sieved through 2.36 mm sieve, and the weight of passing through this sieve is noted down, and let that weight be W2. The aggregate crust value is the percentage of crust material passing through 2.36 mm sieve, and let us consider the weight of that material which is passing through 2.36 mm sieve is W2, and the aggregate crushing value can be determined using the equation W2 divided by W1 into 100. So this is the equipment, or this is the cylindrical measure which is used to know the crushing strength of a aggregate. So first it is filled in this cylindrical measure in three layers, then the aggregate is transferred onto this cylindrical measure in three layers by tamping, by giving 25 blows using a tampered rod of a standard size and standard weight, and after that this cylinder is placed in the instrument and the plunger is allowed to fall on the aggregate. Now coming to the second test, that is abrasion test. So why we need to conduct this experiment? Why we need to know the abrasion strength of a aggregate? So due to the movement of traffic on the road, stones used in the surface course are subjected to varying action at the top. Hence, road stones should be strong enough and it should be hard enough to resist the abrasion due to traffic. To test the hardness property of the aggregate and to decide whether they are suitable for a different pavement construction work. And the abrasion test is standardized as per the Indian Standard 2386 Part 4. So in this figure, in this slide, you can see a abrasion testing machine. So the instrument or machine used for to know the abrasion strength of a material is Los Angeles machine, which consists of a cylindrical drum whose internal diameter is 700 mm and length is 520 mm, and this drum is mounted in a horizontal axis, and this axis can be rotated. So here, along with this drum, an abrasive chargers consisting of cast iron spherical balls of 48 mm diameter and each ball weighing 340 to 445 mm, 340 to 445 grams is placed in the cylinder along with the aggregates. So these are the steel balls which are made up of iron, and the weight of this each ball will be around 342 445 grams, and diameter of this will be 45 mm. So these balls will be placed in the cylinder along with the sample of aggregate. The number of spheres varies according to the gradation of the sample. The quantity of aggregate to be used depends upon the gradation and usually ranges from 5 kg to 10 kg. So after placing the aggregate, the cylinder is locked and rotated at a speed of 30 to 33 rpm for a total of 500 to 1000 revolutions depending upon the gradation of the aggregate. So after specified rotations or revolutions, the material is sieved through 1.7 mm sieve and past fraction is expressed as the percentage total weight of the sample. This value is called as Los Angeles abrasion value. In abrasion test, we should note that the maximum value of 40% is allowed for waterborne macadam base course in Indian conditions, and for bituminous concrete and cement concrete pavements, a maximum value of abrasion strength should be 30%. Now coming to the next test, that is impact test. So here we can see instrument which is used to determine the impact strength or impact value of a aggregate. So here also the test is designed to evaluate the toughness of a stone. So impact means it is a sudden loading. We need to determine what will be the behavior or what will be the resultant of a aggregate due to the sudden loading condition. Now let us see how to conduct the impact test experiment. So firstly, aggregate impact test is carried out to evaluate the resistance to impact of aggregate. So the aggregate passing through 12.5 mm sieve and retained on 10 mm sieve is filled in a cylinder of internal diameter 10.2 mm and the depth of the cylinder will be 5 centimeter. So here you can see this is a cylinder whose diameter is 10.2 mm and depth is 5 centimeter. So the material is filled in 3 layers and each layer is tampered by giving 25 number of blows using a metal hammer, and the weight of metal hammer is around 13.5 to 14 kgs. So after that the cylindrical mold is kept here and the plunger or a weight is removed at this point and it is made to fall on a aggregate. So here the fall of weight is from 38 centimeter. So the hammer will fall from a height of 38 centimeter. So like that the test specimen is subjected to 50 number of blows. So after 50 number of blows from the hammer, the crushed aggregate is allowed to pass through 2.36 mm sieve and the impact value is measured as the percentage of aggregates passing through sieve to the total weight of the sample. So if I consider the aggregate passing through 2.36 sieve as W2 and total weight of the aggregate as W1, then the aggregate impact value or aggregate impact strength is equal to W2 divided by W1 into 100. This gives impact strength of a aggregate, where W2 is the aggregate passing through 2.36 mm sieve and W1 is the total weight of the aggregate. So here the aggregate to be used for varying course, the impact value shouldn't exceed 30%. For bituminous macadam, the maximum permissible value is 35%, and for waterborne macadam base course, the maximum permissible value defined by Indian Road Congress is 40%. So the next test on aggregate is shape test. So the shape test of aggregate is determined by percentage of flaky and elongated particle in it and by its angularity number. So we need to conduct two experiments on to determine the shape test. One is flakiness index and other one is elongation index. So here you can see the two different instruments which are used to know the angularity number of a aggregate. So one is for flakiness index and other one is for elongation index. So first let us see how the flakiness index is conducted. The flakiness index is defined as the percentage by weight of aggregate with whose least dimension is less than 0.6 times their mean size. The sample of aggregate to be tested is first sieved through a set of sieves and separated into specified size ranges. And now separate the flaky materials, the aggregate which passes through the appropriate thickness slot of the thickness gauge are found. And after that, the flaky material passing through appropriate slot from each size range of aggregate are added up and let this total weight of the flaky particles be W1 gram. If the total weight of the sample taken from the different size ranges W gram, the flakiness index can be calculated using the formula 100 into W1 divided by W%, where W is the total weight of the aggregates and W1 is the total weight of flaky aggregates. And the elongation index of an aggregate is defined as the percentage by weight of particle whose greatest dimension is 1.8 times their mean dimension. Here, the sample of aggregates to be tested is first sieved through a set of sieves and separated into specified size ranges. Now, to separate the elongated materials, the aggregates which do not pass through the appropriate elongated slot of the elongated gauge are found. The elongated materials not passing through the appropriate slot from each size range of aggregates are added up and let this weight let this total weight of the elongated particles be W1. If the weight of sample taken from the different size ranges is W, the elongation index is given by 100 into W1 divided by W%, where W is the total weight and W1 is the weight of elongated particles. So that is about aggregates and properties of aggregates and a test conducted on aggregates. Now let us see what is bituminous material. So bituminous materials used in pavement construction works includes both bitumen and tar. So pavement construction work will involve both bitumen as well as tar. So the bitumen and tar is used in the top layer of the pavements. Bitumen is a petroleum product obtained by the distillation of petroleum crude, whereas road tar is obtained by the destructive distillation of coal or tar. So the bitumen is a petroleum product which is obtained by the distillation of petroleum crude, and tar is also obtained by the destructive distillation of coal or wood. So here the crude petroleum obtained from different places is quite different in their composition. The portion of bituminous material present in the petroleum may widely differ depending upon the source. So almost all the crude petroleum contain considerable amount of water along with the crude oil. Hence, the petroleum should be dehydrated first before carrying out the distillation. Generally, types of distillation process are fractional distillation and destructive distillation. In fractional distillation, the various volatile constituents are separated at successive higher temperature without substantial chemical changes, and residue obtained petroleum from this is petroleum bitumen. And tar is the material or a product which is obtained from the destructive distillation of coal or a wood. And when we consider tar and bitumen will be having similar appearance and both are black in color, but they have different characteristics. So bitumen is hydrocarbon material of either natural or pyrogenous origin, found in gaseous, liquid, semi-solid or solid form, and is completely soluble in carbon disulfide and in carbon tetrachloride. So bitumen is a hydrocarbon material of either natural or pyrogenous origin. So pyrogenous origin means it is produced by the com- combustion or application of heat. So bitumen is a complex organic material and occurs either naturally or may be obtained artificially during the distillation of petroleum. So bitumen it is an organic material which can be naturally obtained or it can be obtained during the distillation of petroleum. So naturally obtained bitumen means it is a pyrogenous origin material which is obtained by the combustion or by the application of heat. Bitumen materials are very commonly used in highway constructions because of their binding and waterproofing properties. So bituminous materials are very commonly used because these bituminous materials are having very high binding ability and it is having a very good water resisting property. As a result of this good properties, the bituminous material is more employed in the construction of pavements. When the bitumen contains inert materials or minerals, it is sometimes called asphalt. When the bitumen consists of inert materials or inert mineral, then that material is called as asphalt. So inert material means it is a material whose tendency to do not change. That means the mineral or material which is present in the bitumen will not change its property unless there is any external force or any external agency is acting on that. So when this inert material is present in the bitumen, then that bitumen is called as asphalt. So asphalt is found as deposits in the form of natural asphalts or rock asphalts. The grades of bitumen used for pavement construction work of roads and airfields are called as paving grades. So when we construct a pavement in airports, it is a bituminous pavement and the bitumen which is used in the construction of airfields is called as paving grades. That is, paving grades is the grade of a bitumen. Those used for waterproofing of structures and industrial floors are called as industrial grades. So it is a common practice in recent days to use bitumen as a waterproofing structure in industrial flooring as well as in roofing structure. When the bitumen is used as a waterproofing structure, then it is called as industrial grades. When the bitumen is used in the construction of roads and when it is used in the construction of pavements in airfields, it is called as paving grade. That is, the grade of bitumen is paving grade, and when the bitumen is used in the construction of industrial floors and in the roofs as a waterproofing agent, then it is called as industrial grades. So requirement of bitumen. The bitumen should not be highly temperature susceptible. During the hottest weather, the mix should not become so soft and unstable, and during cold weather, the mix should not become too brittle, causing cracks. So, when the bitumen is subjected to very high temperature, if it becomes soft and if it becomes unstable, what will happen? The top layer of a pavement will get sticked onto the tires of a vehicle. Hence, the bitumen should be very hard even under hottest temperature, and during cold weather the mix should not be brittle. If the mix is brittle and if it undergoes shrinkage during the cold weather, then this results in the cracks and potholes of a top pavement surface. The viscosity of the bitumen at the time of mixing and compaction should be adequate. This can be achieved by use of cutbacks or emulsions of suitable grades or by heating the bitumen and aggregate prior to the mix. So the viscosity of the bitumen at the time of mixing and at the time of compaction should be adequate. That is, the viscosity should be almost same during the time of compaction and during the time of mixing. Hence, the flow of the bitumen and can be good, and we can place the bitumen as per the scheduled plan. So this can be obtained by use of cutbacks and emulsions of a suitable grades or by heating the bitumen and aggregates prior to mixing. So cutbacks and emulsions we shall discuss in coming slides. So there should be adequate affinity and adhesion between the bitumen and aggregates used in the mix. The bitumen should not strip off from the aggregate. So the most important requirement of a bitumen is that the bitumen should have very good adhesion power. Bind it should have a good binding ability with the aggregates. Then only the top surface of the pavement can be very strong, and the bitumen should not strip off from the aggregate during rainy season or during the cold season. So apart from this, in bituminous mix, binders used for binders used form ductile thin layers around the aggregates to serve as a satisfactory binder in improving the physical interlocking of the aggregate. And the bituminous binder should become sufficiently viscous on cooling that the compacted bituminous pavement layer can gain stability and resist deformation under traffic loads. So these are the requirement of a good bitumen. And now coming to the tests on bitumen. So there are number of tests to assess the properties of bitumen material. The following tests are usually conducted to evaluate different properties of bitumen materials. Uh, so the first one is penetration test, ductility test, softening point test, specific gravity test, viscosity test, flash and fire point test, float test, water content test, and loss on heating test. So first let us see what is penetration test. So penetration is the measure of hardness or smoothness of a bitumen. It is it is measured in the laboratory by using a needle which will penetrate vertically in 5 seconds. So the instrument used to know the penetration value of the bitumen is penetrometer. So the penetrometer consists of a needle assembled with a total weight of 100 grams and a device for releasing and locking in any portion. The bitumen is softened to pouring consistency, stirred thoroughly, and poured into container at a depth at least 15 millimeter in excess of expected penetration. And the test should be conducted at specified temperature of 25 degrees Celsius. It may be noted that the penetration value is largely influenced by any inaccuracy with regards to pouring temperature, the size of the needles, weight placed on the needle, and the test temperature. A grade of 40 by 50 bitumen means the penetration value in the range of 40 to 50 at standard test condition. In hot climates, a lower penetration grade is preferred. And the second test on bitumen is ductility test. So here the ductility is the property of bitumen that permits it to undergo great deformation or elongation. So ductility is defined as the distance in centimeter to which a standard sample or briquette of the material will be elongated without breaking. The dimension of the sample thus formed is exactly 1 centimeter square. The bitumen sample is heated and poured in the mold assembly placed on a plate. And here, these samples with mold are cooled in the air and then in water bath at a temperature of 27 degrees Celsius. The excess bitumen is cut and the surface is leveled using hot knife. Then the mold with assembly containing the sample is kept in the water bath of the ductility testing machine for about 90 minutes. The sides of the molds are removed, the clips are hooked on the machine and the machine is operated. The rate of pulling is about 50 mm per minute. The distance up to point of breaking of thread is ductility value, which is reported in centimeter. The ductility value gets affected by factors such as pouring temperature, test temperature, rate of pulling, etc. So the next test on bitumen is the softening point test. Softening point denotes the temperature at which the bitumen attains a particular degree of softening. Under the specification of the test, the test is conducted by using a ring on ball apparatus. A brass ring consisting a 10 test sample of a bitumen is suspended in liquid like water or glycerin at a given temperature. A steel ball is placed upon the bitumen sample and the liquid medium is heated at a rate of 5 degrees centigrade per minute. Temperature is noted when the softened bitumen touches the metal plate, which is at specified distance below. Gradually, higher softening point indicates lower temperature susceptibility and is preferred in hot climates. So next test is specific gravity test. So in paving jobs, to classify a binder, density property is of great use. In most of the cases, bitumen is weighed, but when used with aggregates, the bitumen is converted to volume using density values. The density of bitumen is greatly influenced by its chemical composition. Increase in aromatic type mineral impurities cause an increase in specific gravity. The specific gravity of bitumen is defined as the ratio of mass of a given volume of bitumen of known content to mass of equal volume of water at a standard temperature. The specific gravity can be measured using either pycnometer or preparing a cube specimen of bitumen in semi-solid or a solid state. The specific gravity of a bitumen varies between 0.97 to 1.02. So the next test on bitumen is viscosity test. So viscosity denotes the fluid property of a bitumen material and it is a measure of resistance to a flow. At the application of temperature, this characteristics characteristic greatly influences the strength of resulting paving mixes. Low or high viscosity during compaction or mixing has been observed to result in lower stability values. At high viscosity, it resists the compactive efforts and thereby resulting mix in heterogeneous. Hence, low stability values and at low viscosity, instead of providing a uniform film or aggregate, it will lubricate the aggregate particles. Orifice type viscometers are used to indirectly find the viscosity of the liquid binder like cutbacks and emulsions. The viscosity expressed in seconds is the time taken by the 50 ml bitumen material to pass through the orifice of a cup. Under standard test condition, the specified temperature viscosity of cutback bitumen can be measured with either 4 mm orifice at 25 degree Celsius temperature or 10 mm orifice at a temperature between 25 to 40 degree Celsius. And the next test on bitumen is flash and fire point test. So at higher temperatures, depending upon the grade of bitumen material, leaves out volatile and this volatile catches fire, which is very high hazardous and therefore it is essential to qualify this temperature for each bitumen grades. So as per the specification of BIS, the flash point is the temperature at which the vapor of bitumen monomentarily catches fire in the form of flash under specified test conditions. The fire point is determined as the lower temperature under specified test condition at which the bitumen material gets ignited and burns. The seventh test on bitumen is float test. So normally, the consistency of bituminous material can be measured either by penetration test or viscosity test. But for certain range of consistencies, these tests are not applicable and float test is used. The apparatus consists of aluminum float and a brass collar filled with bitumen to be tested. The specimen in the mold is cooled to a temperature of 5 degrees Celsius and screwed into float. The test assembly is floated in water bath at a temperature of 50 degrees Celsius and the time required for the water to pass its way through the specimen plug is noted in seconds and it is expressed as the float value of the bitumen. And eighth test. The next test on bitumen is water content test. It is desirable that the bitumen contains minimum water content to prevent foaming of the bitumen when it is heated above the boiling point of water. Here, the water content in the bitumen is determined by mixing with known weight of specimen in a pure petroleum distilled free from water, heating and distilling of the water. The weight of the water condensed and collected is expressed as the percentage by weight of original sample. The allowable maximum water content should not be more than 0.2% by the weight. And the last test on bitumen is loss on heating test. So when the bitumen is heated, it loses the volatility and gets hardened. About 50 gram of sample is weighed and heated to a temperature of 163 degrees Celsius for 5 hours in a specified oven designed for this test. The sample specimen is weighed again after heating period and loss in the weight is expressed as the percentage by weight of original sample. The bitumen used in pavement mixes should not indicate more than 1% loss in weight, but for bitumen having penetration value between 150 to 200 mm can have up to 2% loss in weight is allowed. Different forms of bitumen. So till now we discussed what is a bitumen and what are the characteristics of a bitumen and what are the tests that is carried out to determine the properties of a bitumen. And now let us discuss about different forms of bitumen. So there are four classes under the bitumen or bitumen is divided into four categories. One is cutback bitumen, bitumen emulsion, bituminous primer and modified bitumen. So first let us see what is a cutback bitumen. So the cutback bitumen is obtained by blending bitumen binder with suitable volatile dilutes or the bitumen is blended with solvents in the required proportion to reduce the viscosity to the required range. And here the solvent from the bituminous material will evaporate and the bitumen will bind the aggregate. So the cutback bitumens are used for cold weather bituminous road construction and maintenance. The distillates used for the preparation of cutback bitumen are kerosene, diesel, etc. The rate at which the cutback bitumen hardens on the road surface depends upon the characteristics and the quality of a volatile liquid or a volatile oil which is used as the diluents, and also on the atmospheric temperature and humidity at the work site. So the cutback bitumen binders or approximate type of grade is selected for use as a track coat without the need of heat. So this binder is particularly preferred for use in sites at sub-zero temperatures and in regions of high altitude. These cutback bitumens are divided into three types, or we have three different types of cutback bitumens. One is rapid curing, medium curing, and slow curing. So the type of bitumen used in the construction of pavement depends upon the importance of the project. So what are the tests that is carried out on a cutback bitumen? So the tests which are carried out on a bitumen, same test are carried out for the cutback bitumen. So the tests like kinematic viscosity, distillation test, flash point test, viscosity test, ductility test, and water content test. So these are all the tests that the cutback bitumen will undergo. Now coming to the second bitumen form, that is bitumen emulsion. So bitumen emulsion is a liquid product in which bitumen is suspended in a finely divided condition. An emulsion is two-phase system consisting of two immersible liquids, the one being dispersed as fine globules in the other. And the function of this emulsifier is to form a protective coating around the globus of binder, resisting the collisions of the globus. And these emulsifiers usually adopted are soaps, surface active agents, and colloidal powder. So here also we have three types of bituminous emulsion. So one is rapid setting, medium setting, and slow setting bituminous emulsion. And the main advantage of this bituminous emulsion is this can be used without heating for sparing or preparing the mixes, and they are particularly useful for patch repair works and can be used even surface is wet. So this is the advantage of this bitumen emulsion, that is it can also be used in the repair work when the surface is wet. And the bitumen emulsions are used in spray application like track coat or for the surface treatment for surface dressing and penetration macadam. So the major use of this bitumen emulsion is in the repair work of bridge ducts. So sometimes these bitumen emulsions are used as a prime coat, and this is also used as a soil stabilization. Then what are the tests that is conducted on bitumen emulsion? So few tests conducted on bitumen emulsion are viscosity test, water content test, settlement test, cement mixing ability test, then particle charge test, and coating test. So these are the tests that the bitumen emulsion will undergo. The next form of bituminous primer. So bituminous primer, the distillated is absorbed by the road surface on which it is spread. The absorption therefore depends on the porosity of the surface. If the surface is having more porosity, then absorption of the bituminous primer will be more. The bitumen primer are very useful on the stabilized surface and waterborne macadam base course. This bituminous primers are generally prepared on roadside by mixing penetration bitumen with petroleum distillation. Then fourth form of bitumen is modified bitumen. So the modified bitumen, in this modified bitumen, what we will do is we are going to add the modifiers for a bitumen. So why we are going to add some agents or some modifiers for a bitumen is because the viscosity of ordinary paving grade bitumen varies considerably with temperature. So as a result of this, the bituminous pavement surface course also becomes susceptible to temperature changes. So during hot weather, the bituminous surface course becomes soft, resulting in possibility of permanent deformation and early rutting along with the wheel parts of heavy vehicle. And during cold weather, the bituminous pavement surface course becomes very stiff and brittle with possibility of early cracking under repeated application of heavy wheel loads. Hence, we need to retain the strength of a bituminous surface. Hence, certain additives or certain blend of additives are added to the ordinary bitumen and it is called as bitumen modifiers. So this bitumen modifiers can improve the properties of bitumen and bituminous mix, and the bitumen treated with this modifiers is called as modified bitumen. The advantage of using the modified bitumen in the construction of pavement is the better age resistance properties, higher fatigue life for mixers, prevention of crack and reflective cracks, better adhesion between aggregates and the binder. And when we use the modified bitumen, the most important or the very advantageous thing is it is very lower susceptible to daily and seasonal temperature variation. So these are the advantages of using bituminous modified bitumen. So these are the different forms of bitumen. So next is the tar. So I already told you that the tar and bitumen looks similar. The color of tar and the color of bitumen is almost the same, but the properties of tar and characteristics of tar is different from that of properties and characteristics of a bitumen. So up to previous slide, we discussed about bitumen and different forms of bitumen, how bitumen is obtained and what are the tests conducted to know the properties of the bitumen. And now let us discuss what is a tar and how the tar is obtained, what are the advantages of tar and what are the tests conducted on a tar. So tar is the various liquid obtained when natural organic material such as wood and coal carbonized or destructively distilled in the absence of air. So when wood or a coal is carbonized, the product obtained is called as tar. Or when there is a destructive distillation of this wood or coal in the absence of air, the product obtained is called as tar. So based on the material from which the tar is derived, it is referred to as wood tar or coal tar. If the tar is obtained by carbonization of wood, then the tar is called as wood tar, and if the tar is obtained by carbonization of coal, then the tar is called as coal tar. So like this, depending upon the material, the tar is referred. So there are 5 grades of road tars like RT1, RT2, RT3, RT4 and RT5. So based on their viscosity and properties. So tar is divided into 5 grades like RT1, RT2, RT3, RT4 and RT5. So the tar has different grades based on their viscosity and other properties. Suppose if I consider RT1, so RT1 is a grade of tar which has the lowest viscosity and is used for surface painting under exceptional cold weather, as this has very low viscosity. And if I consider the tar grade RT2, so RT2 is recommended for standard surface painting under normal Indian climatic condition. Then coming to the next grade, that is RT3. So RT3 may be used for surface painting, renewal coats and pre-mixing chips for top coats and light carpets. And the uses of grade RT4 is generally used for pre-mixing tar macadam in base course, and it is also used for grouting purpose. Then RT5. So RT5 grade may be adopted which has the following viscosity among the road tars. So RT5 is having a highest viscosity among the road tars, and hence here the RT5 is having more viscosity compared to RT1, RT2, RT3 and RT4. Hence in the construction of pavement we can give the first preference for RT5. And now what are the tests carried out on tar? So the tests carried out on tar are specific gravity test, viscosity test, sound softening point test, float test, water content test, test for matter insoluble in tolerance, distillation fraction. So these are the tests that is carried out on the tar to determine the specific properties and values of the tar. So these tests are conducted with the same procedure as what we will do in bitumen. So what's the difference between bitumen and tar? So here we have the difference between bitumen and tar. So in your semester examination, so they may ask you a question to differentiate between bitumen and tar for 5 marks. So many times they have asked a question to differentiate between bitumen and a tar for a 5 or 6 marks. So from your exam point of view, this is very important. So bitumen. So bitumen, it is a petroleum product. Tar. So tar is obtained by destructive distillation of coal or a wood, or tar is produced by carbonization of coal or a wood. So bitumen is soluble in carbon disulfide and in carbon tetrachloride. So tar is soluble in any tolerance. So bitumen has more weather resisting property, whereas tar has very less resisting weather resisting property. So tar is less temperature susceptible and bitumen is more temperature susceptible. So the free carbon content is less in bitumen and carbon content in tar is more, because the tar is a product of carbonization of coal or a wood, hence the carbon content will be more in the bitumen.